Introduction to sequences. Each number is called a term. So this one is term number 1, term number 2, term number 3, term number 4, and then this one's term number 1, term number 2, term number 3, and so on. Now, a sequence has to follow a pattern. In this case, if we get from 1 to 3 to 5 to 7, we know that we are adding 2. In this case, we've got from a third to a ninth to 1 and 27th, so we know that we are multiplying by 1/3. Now, to get the next number, we just got the one before it and added 2. Got this one and added 2. And we'll just concentrate on this one here. So there it is. How do we signify this? So we label it. We got t of n equals t of n minus 1. N is the next term. N minus 1 is the previous term. So if n equals to 2, I'll get t of 2 equals t. 2 minus 1 gives me 1 plus 2. I already know what t of 1 is. They tell me that. That's 1. So 1 plus 2, which gives me 3. Okay, and so on and so on and so on. Sometimes we don't need to write that like this. We can write it as t of n plus 1. So the next term is the term before it plus 2. These are known as recurrence relations or recursive formula or iterative rules. So we have to be able to do that. This is the same, the next example there. So I won't go through that. I'll go to the first example. It says use the recurrence relation to find the first 4 terms of the sequence. So they're giving me 1, so my next one has to be 2. So I want n to be 2. Now you don't need to do all this, but when n equals 2, you get t of 2, which equals t of 1 plus 5, which is going to be 3 plus 5, which means it's 8. So t of 2 equals 8. I know that this is what's happening. 5 is getting added to it. So t of 3 will be 8 plus 5, 13. T of 4 will equal 13 plus 5, 18. And I can keep going. It says to find the first 4 terms. We had 1, 2, 3, and there's the fourth one. Example 2, find the recurrence relation for the following sequence. So this time we have to find that recurrence relation. So let's see what's happening. We go from 9 to -3, then from -3 to 1, then from 1 to -1/3. So we are doing something. We are multiplying by -1/3. So I can write my rule straight away. T of n will equal -1/3 using the term before it. And the term before it is n minus 1. We should say that t of 1 has to equal 9 because we need a starting point. If we don't have a starting point, then we can't do it. Example 3 says find the first 4 terms of the sequence defined by that rule. Now this rule has a couple of things happening. It's multiplying the n and then it's adding the 3. So again we put n equal to 1 first. So we get t of 1 equals 2 times 1, which is 2, plus 3, so that's 5. Then t of 2. If you put n equal to 2, you're going to get 2 times 2, which is 4, plus 3, which is 7. If you put n equal to 3 to find the third term, you're going to get 2 times 3, which is 6, plus 3, which is 9. And term number 4, you're going to get 2 times 4, which is 8, plus 3, which is 11. And then we can see we're just adding 2 all the time. I won't write them all out, but the first 4 terms are, but I might do it for this one here and nothing else. The first 4 terms are 5, 7, 9, 11. Example number 4. Find a rule for the nth term of the sequence 1, 4, 9, 16 in terms of n. So let's see what is happening here. It's going 1, this is term number 1, then term number 2, term number 3, and term number 4. So if we link these numbers 1, 2, 3, and 4 to this, 1 to 1, 2, 9, and 16, what seems to be happening is we're getting the term n and we are squaring it. So t of n equals n squared and t of 1 equals 1. We don't really need that one of this because we have this rule which gives us the n anyway. Example 5. At a particular school, the number of students studying specialist maths increases each year. Presently 40 students, so it gives us a starting value, studying specialist maths. Part A, set up a recurrence relation if the number is increasing by 5 students each year. Okay, so part A, to get the next year, we have to get the previous year, which is n minus 1, and we are adding 5 because it increases by 5. And of course we know that t of 1 equals 40. Part B, write down an expression for t of n in terms of n. So this part A, we just worked out the recurrence relation. This is t of n in terms of n. So we don't have the n minus 1 or the n plus 1. We have it timesing by n. So if I look at it, it's my terms are 40, and I add 5 because that's what's happening, so 45, and I add 5 again, so 50. So really, my t of n, which is in terms of n now, becomes 40, my starting value, plus 5, not 50, it goes up by 5n. So if I look at it, when n equals, I better write n minus 1, because I've got n there. So, and I'll just double check this. I'll do this in red. So t of 2, because I already know the first term, t of 2 will be 40 plus 5, 2 minus 1, which will be 45, which I know is going to be 45. Not a problem. So there's my rules correct. C. Find the number of students expected to be studying specialist maths at the school in 5 years' time. So we know the rule and we want t of 5. So we got 40 plus 5. 5 take away 1, which is going to be 40, plus 5 times 4. 4 times 5 is 20, so 40 plus 20. 60 students will be studying it in 5 years' time. Again, I'm not going to write it in words, but you guys should. Example 6. The height of a sand dune is increasing by 10% each year, currently 4 meters high. So again, it gives me the starting value. And I know what's happening. Set up a recurrence relation that describes the height of the sand dune. Okay, in this case here, to get the next one, we're going to get the one before it, and it's going up by 10%. Now 10% means it's 10 divided by 100, which equals 0.1. But we need the original 4 meters, so we have to add the 1 or the 100% first, so we got 1.1. So we're going to times this by 1.1. Okay, now I shouldn't leave it like that. I should by 1.1 t of n minus 1, just to write it better. Part B, write down an expression for t of n in terms of n for this recurrence relation. Okay, well, if we do it, we're going to get the first answer is 4. Then timesing that by 1.1 gives me 4.4. And timesing that by 1.1, 4.4 times 1.1 gives me 4.84. So there's my recurrence relation. And now I'll write it in terms of n. So t of n will equal 4, my starting value, times 1.1. And this is a power because it's always been multiplied by 1.1. So it's the first one times, 2 1.1s and then 3 1.1. So this is going to be n minus 1. And I'll leave that one like that. Part C, find the height of the sand dune in 7 years' time. So we want t of 7. 4 times 1.1 to the 7 minus 1, which is going to be 6 to the power of 6. And when you work that out, it's going to be approximately 7.795 meters. Example 7 says use a calculator to generate the first 10 terms of the sequence of numbers defined by that rule there. Okay, so you can put your rule in, and if you want, you can actually specify what n is. Okay, all those numbers, and then put our rule in, and when we press enter, it's going to give us the answer. So we can do it like that. That is not a problem. You can do it, of course, 1 plus, do it separately. You can set your calculator by going 3 plus 4 times 1, and that gives you the 7. And then you can do 3 plus 4 times 2, and so on and so on. So it's up to you how you want to do it. Example A, to use a CAS calculator to generate the sequence defined by this one here. We can do this on the spreadsheets, lists and spreadsheets. I'll let you follow it. There it is there, and also continues on the next page.